Dear children, previous video we have learned types of numbers, that is natural numbers, whole numbers, integers and rational numbers. Now we are going to study another type of numbers. They are called irrational numbers. These natural numbers, whole numbers, integers and rational numbers. Natural numbers are rational numbers. Whole numbers are rational numbers. Integers are also rational numbers. How many types of numbers we have studied? All are rational numbers. That means all the numbers we can write it in the form p divided by q. Whether it is integers or whole numbers or natural numbers, so we can write it in the form of p divided by q. So far how much types of numbers we have studied? All the numbers are rational numbers. Now some other types of numbers are there which cannot be written in the form of p divided by q, where p and q are integers and q not equal to 0, are called irrational numbers. Numbers which cannot be written in the form of p divided by q, where p and q are integers and q not equal to 0, are called irrational numbers. Example, root 2 is an irrational number. Root 2 is an irrational number. Root 3 is an irrational number. Root 5 is an irrational number. Root 6 is an irrational number. Root 7 is an irrational number, etc. Square root of all non-perfect squares are irrational numbers. Square root of all non-perfect squares. Which are the perfect squares? 1, 4, 9, 16, 25, 36, etc. are called perfect squares. Square root of 1 value is there 1, square root of 4 2, square root of 9 3, square root of 16 4, square root of 25 5, square root of 36 6, etc. So these numbers are called perfect squares. These numbers are non-perfect squares, that is 2, 3, 5, 6, 7, 8, after that 10 only, square root of 8, but square root of 9 is not an irrational number. Square root of 9 is equal to value is there, that is 3. Square root of 9 is equal to 3. So it is a rational number. 3 we can write it in the form 3 divided by 1. It is a rational number only. But root 8 is an irrational number. Next one, root 10 is an irrational number. Root 10 is an irrational number. So square root of all non-perfect squares are irrational numbers. And cube root of all non-perfect cubes are irrational numbers. Cube root of 2 is an irrational number. Cube root of 4 is an irrational number. Cube root of 5 is an irrational number, etc. These are non-perfect cubes. But cube root of 8 is a rational number. Cube root of 8 is equal to what is answer? 2. Cube root of 8 is a rational number because cube root of 8 is equal to 2. But these cube root of 2, cube root of 4, cube root of 5, etc. are irrational numbers which cannot be written in the form of p divided by q. And again, we know that pi, to find out the area of a circle or circumference of a circle, or in a cylinder, cone, etc. we use this pi. What is the value of pi? Pi is equal to, for the calculation we use 22 divided by 7 or 3.14, but it is not the actual value. Pi is an irrational number. We cannot write it in the form of p divided by q. This 22 divided by 7, you may get confusion. 22 divided by 7 is a rational number. It is in the form of p divided by q, but it is not the actual value of pi. It is not the original value of pi. Pi value is 3.1458767653, etc. It will go on. It will not stop. Then that is, if you are finding out the value of pi after the decimal point, many digits will repeat. It will not stop, and the same numbers are not repeating here. That is why this number we cannot write it in the form of p divided by q. So it is an irrational number only. So remember that pi is an irrational number. In the next exercise, there is a multiple choice question. There is a question: pi is a or an irrational number, a rational number, integer, etc. It is given there. Then that is, remember, pi is an irrational number. Don't get confusion there. For the calculation only we are using this 22 divided by 7 or 3.14. But its actual value is 3.14587653 etc. It will go on. So we cannot write it in the form of p divided by q. So pi is an irrational number. So just remember these examples. Root 2 also is an irrational number. Root 3 is an irrational number. Root 5 is an irrational number. So this just an example you remember. And it's a proof you will study in class 10 only. We can prove that root 2 is an irrational number. That proof you will study in class 10 only. So now just remember this one. That is irrational numbers. Some numbers are there, not only irrational numbers, some numbers are there, some other type of numbers are there which cannot be written in the form of p divided by q, where p and q are integers and q not equal to 0 are called irrational numbers. These are the examples of irrational numbers. Square root of all non-perfect squares are irrational numbers. Cube root of all non-perfect cubes are irrational numbers. And pi is an irrational number, and many other numbers are there. Rational numbers also we have studied. Infinite number of rational numbers are there. Infinitely many numbers are there, rational numbers. The same way irrational numbers are also there. Infinite number of irrational numbers are there. And next one, these all the irrational numbers we can represent it on a number line. On a number line, we have studied earlier. On a number line we can represent these rational numbers. All the rational numbers we can represent it on a number line. If you are drawing a number line 0, 1, 2, 3, 4 etc. minus 1, minus 2, minus 3 etc. This one is a number line. All the rational numbers we can represent in on a number line. Last day we have studied that one. That is, here it will come 1 divided by 2, then 3 by 4 or 4 by 5 etc. All the rational numbers we can represent it on a number line. The same way, these all the irrational numbers are also we can represent it on a number line. So remember, all the rational numbers and irrational numbers we can represent it on a number line. Irrational numbers can be represented on a number line. So every point on a number line represent either rational number or an irrational number. And now, previous class I told that just if we are working on a number line, then collect this 1, 2, 3 etc. on a byte, then put it inside the byte. Then these numbers are called the natural numbers. After that we will come back and we will collect this 0 and we will put it in the byte. Then it is called whole numbers. After that we are walking through this left side of the number line and collecting these all the negative numbers. Now in our byte all the integers are there. That collection of that all the numbers are called integers. After that I told these collecting these all the rational numbers, that is numbers which can be written in the form p divided by q. Collecting all the numbers and putting inside the byte means now we have the rational numbers in our byte. Then if we are, and now I told that here on this number line irrational numbers are also there. If we are collecting that all the irrational numbers and putting inside this byte, now you see inside our byte rational numbers are there and irrational numbers are also there. So this collection of all the rational numbers and irrational numbers together called real numbers. That is together called real numbers, and it is denoted by the letter capital letter R, real numbers. Collection of all the rational numbers and irrational numbers together called real numbers, and it is called denoted by the letter R. Now these all the rational numbers and irrational numbers can be represented on a number line. That is why this number line is called, actually it is called a real number line. It is called a real number line. So this much you have to remember, and proof of this irrationality, that you will study in class 10 only, I told that. Now we will start the next exercise, that is exercise 1.2. Okay, now see the question. Exercise 1.2, question number B1. It is question number B1. State whether the following statements are true or false. Justify your answers. State whether the following statements are true or false. 3 statements it is given here. We have to say that whether it is true or false, and you have to justify your answer. Reason you have to write why it is true or why it is false. See the first question. Every irrational number is a real number. Every irrational number is a real number. Already I told that what is by real numbers. The collection of all rational numbers and irrational numbers together called real numbers. So every irrational number is a real number. That is true. So we can write answer true because the collection of rational numbers and rational numbers and irrational numbers are called real numbers. So every irrational number is a real number because the collection of rational numbers and irrational numbers are called real numbers. Now see question number 2. Every point on the number line is of the form root m where m is a natural number. Every point on the number line is of the form root m where m is a natural number. That is false. That statement is false because what is the reason? Because no negative number can be the square root of a natural number because no negative number can be the square root of a natural number. Can be the square root of a natural number. Negative numbers are also there in the number line. Here it is given every point on the number line is of the form root n. We know that negative numbers are also there on the number line. That here it is given m is a natural number. So negative number it will not come. No negative number can be the square root of a natural number. So that statement is false. Now third one is every real number is an irrational number. Number 3. Every real number is an irrational number. All the real numbers are irrational numbers or not? No. Just now we wrote here. The collection of rational numbers and irrational numbers are called real numbers. So all the real numbers are not irrational numbers. In the real numbers, rational numbers also will come. So it is a false statement. Every real number is an irrational number. That is false. Just we can write an example. That is because 2 is a real number. 2 is a real number. But it is not irrational. It is not irrational. So every real numbers is not an irrational number. 2 is a real number, but it is not an irrational number. So that is a false statement. So that is the answer. Okay, now question number 2. Are the square root of all positive integers irrational? Square root of all the positive integers are irrational or not? That is the question. If not, give an example of the square root of a number that is a rational number. Give an example of the square root of a number, square root of a natural number that is a rational number. Are the square root of all positive integers irrational? No. Square root of all the positive integers are not irrational. Example, root 4 is equal to, we know that answer, 2, which is a rational number. That much only the answer. Square root of all positive integers irrational. Square root of all the positive integers. Take all the positive integers. Square root of 1, square root of 2, square root of 3, square root of 4, square root of 5, etc. All these are irrational numbers or not? That was the question. We know that it is not an irrational number. Root 1 is equal to what is the answer? 1. Root 4 is equal to what is the answer? 2. 1 is a rational number. 1 we can write as 1 divided by 1. 2 is a rational number. 2 we can write as 2 divided by 1. But root 2 is an irrational number. Root 3 is an irrational number. Root 5 is an irrational number. So all the square root of all the positive integers are not irrational numbers. So that we wrote answer here. No. One example we have to write. Square root of 4 is equal to 2, which is a rational number. Okay, now question number 3. Show how root 5 can be represented on the number line. Show how root 5 can be represented on the number line. Already I told that all the irrational numbers also we can represent it on a number line. Not only irrational numbers also we can represent it on a number line. Root 5 is an irrational number. How can we represent it on a number line? That we are going to do. Then we can represent it on a number line. So first you have to draw a number line. Both sides give arrow mark. Then mark a point here, 0. Left side it will come negative numbers. Right side it will be positive numbers. Then while marking this, here we are going to mark it 1, 2, 3 like that we are going to mark it on the number line. While marking, if we are marking exact 1 centimeter means that figure will be very small. So you have to mark it 2 centimeter and there we will mark 1. That means 2 centimeter we will take it as 1 unit. 2 centimeter. Here I am marking 2 centimeter. 1 centimeter means up to here only it will come. So it will be very small. Figure will be very small. You can mark 2 centimeter or 3 centimeter. No problem for that. I am marking here 2 centimeter. Then again next 2 centimeter. Again next 2 centimeter. Like that we are going to mark. Then here. And left side also if you want to mark you can mark it. Here 2 centimeter I have marked here 1 point. And left side also we will mark 1 point as 2 centimeter. Here it is. This one is minus 1. So here we can mark minus 1. And this one is 1, 2, 3, etc. it will come. So now, this one, remember that if you are taking this one 1 centimeter in your scale, figure will be very small. Better to take 2 centimeter or 3 centimeter also you can take. If you are taking 3 centimeter and marking here point means this one also should be 3 centimeter. Here also we have to mark 3 centimeter. Then after that now we will draw a perpendicular through the point 2. Perpendicular to this number line. So for that you have to take your compass. 2 as center. First you will draw an arc here. And don't change this radius. Now here we got a point. That point as center. Cut that arc. Again now we got a point here. Taking that point as center. Draw an arc here. Don't change the radius while drawing this one. Again, here we got a point. Using that point as center, cut that arc here. So now we will get a perpendicular there. That means here we made 90 degree, that much only. Then join that point 2 and this point. Here we got a point now. That point we have to join. And draw a little upside there. And give an arrow mark there also. We have drawn a perpendicular. This one made it 90 degree. Then that line will be perpendicular to this number line. Now we have to measure this one with your compass. You measure it 2 centimeter. This one, if you have taken 2 centimeter here, that you measure it. This one is 2 centimeter. And that same 2 centimeter you have to mark it on this line. Here we will mark it. Now these points you have to mark here. This one is actually 0, but we will consider it as O, and here we will mark a point A. This point 2 is A, and here we have marked a point here, that is B. Now we will join OB. O and B we will join. O and B, OB. Now you see, OA is equal to how much unit is here? That is 2 unit, and AB is equal to 1 unit. Mark it there. Here this 2 centimeter, that exact 2 centimeter we marked here, so that is 1 unit. 2 centimeter we have marked, but that is we are considering it as 1 unit only. So AB is equal to 1 unit. Now you see, now we got a right angle triangle, that is OAB is a right angle triangle because here we made a 90 degree. This one is perpendicular, so that is 90 degree. So OAB is a right angle triangle. By using Pythagoras theorem, now you will find out the length of OB, that is the hypotenuse. So here we have to find out. Right side you write it in right triangle OAB by Pythagoras theorem. Pythagoras theorem, we get, what do you get? OAB is a right angle triangle. In this right triangle we are using that Pythagoras theorem. In right triangle OAB by Pythagoras theorem, what is Pythagoras theorem? Hypotenuse square is equal to perpendicular square plus base square. Hypotenuse, which one is the hypotenuse in this right triangle? Opposite side of the right angle. Opposite side of the right angle is OB. So OB is the hypotenuse, AB is the perpendicular, and OA is the base. So hypotenuse, that is OB, we can write OB square is equal to perpendicular square, that is AB square plus base square, that is OA square. OA is the base of that right triangle, so that is OA square. Now OB square is equal to AB square, that is AB is equal to how much centimeter? That is 1 unit we have taken. AB square, that is 1 square plus OA square. OA is equal to 2 unit, that is 2 square. Then that is equal to OB square is equal to 1 square, that is 1 plus 2 square, 2 2s are 4. OB square is equal to 1 plus 4, that is 5. OB is equal to square transposing to next side, we will get answer square root, and right side 5 is there, so it will come OB is equal to root 5. So what is the length of OB? OB is equal to square root of 5. Now that root 5 we have to mark it on this number line with the O as center and OB as a radius. OB as a radius, we have to draw an arc. O as center, OB as radius. That means this OB length is root 5. OB length is root 5. That we are going to, here dotted line only, this OB as radius, you have to draw an arc. It should be dotted line. It should be dotted line. And where it will touch on the number line, that point is root 5. From here to here, it is 1 centimeter. From here to here, it is 2 centimeter. From here to here, it is root 5 centimeter. So this one is the point root 5 on the number line. So here we have to mark it root 5. Now we have represented root 5 on the number line. That is the answer. Now next question, represent root 7 on a number line. How can we represent root 7 on a number line? Root 7, now you see here we have represented root 5. Again, to represent root 7, same root 5 we have to make. After that, here we will make root 6. Again we will make root 7. So that I will show you in the next video. Thank you so much.